Good evening, everyone. Thank you for joining us to our 1 year to COP, Introduction to Climate Issues and Glasgow's COP for young people. We're delighted to have you all with us this evening. I have a few housekeeping points that I'll go through before we get started. Just to let you know, this session is being recorded and it will be available to view after the webinar. We ask that you don't take any photos or screenshots of people, but please do share your thoughts on social media with the hashtag 1 year to COP and tag us at RSPB Scotland. You'll notice the Q&A box at the bottom of your screens has been activated, so please post any questions that you have throughout the presentations in the Q&A box, which will be monitored by my colleagues Rebecca and Sarah Jane. And we'll be doing short Q&A sessions after each presentation rather than all at the end. But we may also have some time towards the end to add in any additional questions. So please make use of that throughout the sessions if you have particular questions. If we run out of time for that, we may not be able to get through all of the questions, but please do put them in anyway, and we'll get back to you directly after the event. We also have a range of ages of people attending today, so I have a few safeguarding points to mention. If you are under the age of 16, you will need to have a parent or trusted guardian with you while you're watching this. And as this is a webinar, your video and audio has automatically been disabled, which means no participants will be able to see or hear each other except from the panelists. We've also recommended that you join the webinar from a communal space in your home where possible. We also kindly ask that you make this a positive and safe space for everyone. Discussing climate issues can be challenging and emotional for many of us, so we ask that you are respectful during this session. Bad language or offensive comments will not be tolerated. It is World Kindness Day today as well, so please do bear that in mind when you're speaking or messaging other people. We're delighted to have you all able to join us this evening for the 1 year to COP event, marking 1 calendar year until the postponed UNFCCC COP26 to be held in Glasgow. If you're not quite sure what that means, one of our speakers later on will be able to tell you so much more about that. As I said, my name is Kate and I'm the COP26 Climate Change Youth Officer with RSPB Giving Nature a Home in Glasgow and Edinburgh that has been working in these cities for the last 7 years. This climate change project began in early March of this year, and we, as many people, had high hopes for lots of face-to-face meetings, workshops and celebrations, but like many others, 2020 has had other plans. We have been resourceful and, like many others, have been learning how to work with and for young people virtually. I've been meeting regularly over the last 8 months through virtual meetings with a fantastic group of young people who have helped co-create today's sessions and have made this event possible. Thank you very much to them. We have spent time exploring how we meet online, how COVID-19 has changed our daily lives, and how to work collaboratively to reach fellow young people about climate change, biodiversity loss, and the importance of COP26. One of the key themes that came out of our conversations with our young people was the challenge of finding accessible information about COP26 and why it's relevant and important to young people. So today we're going to take you on a bit of a short journey, which will hopefully give you some background and context for why COP26 is relevant to young people. We're going to pull up a quick poll for everyone to participate in, just to give us an idea of how informed you all are. The question asks, how informed do you feel about the topics we will be talking about today? Your options are very informed, quite informed, a little informed, not informed at all, or I'm not sure. Please cast your vote just now and we'll have a look at the results in just a second. Fantastic. So we have some very informed people on the call this evening, which is great. Thank you very much for coming along. And there are other people who are keen to learn more. So thank you so much for joining us. So we have a fantastic range of speakers this evening. We have Fiona Dobson from RSPB, Armstrong from Dynamic Earth, We have Euan Furness and Hinson from the Grantham Institute. And we also have Rachel Osgood from UN House Scotland, who will all be talking about slightly different subjects, but lead up to this idea and context of COP26. So without further ado, I'm going to introduce you to Fiona Dobson, who will then start her presentation. So Fiona has worked as the Global Policy Assistant at the RSPB since January of this year. Her work spans international biodiversity and climate policy, working to raise global ambition for strong international environmental agreements, especially the UN Convention on Biological Diversity and the UNFCCC. She also works to connect global policy with local actions, especially through promoting nature-based solutions.
Hello everyone, thank you very much for the introduction, Kate. I'm really excited to be speaking to you all today and kicking off this evening's session. Hopefully my slides are up on the screen for you. So my plan is I'm going to introduce some of the main concepts and ideas that we'll be talking about this evening. And then the other speakers are going to go into a little bit more detail for you. And then, as Kate said, you can ask questions that you have after each of our talks. So I'm going to be sharing with you the fact that nature and climate are deeply interlinked. So if you like, they are two sides of one coin. So what we do to climate affects nature, and then what we do to nature affects climate. But what's happened is that often when people talk about climate change and consider it in debates, they kind of forget what that means for nature. But in actual fact, nature is one of the biggest solutions that we have to tackle climate change. Therefore, we really need to bring it into the conversation more. So to get us started, I'm going to talk about how we have these two big crises that we're facing. The fact that you're here at the moment means that you know about climate change, most likely, and that is the fact that our activities as humans have been leading to the release, such as the way we generate our electricity, for example, have been leading to the release of greenhouse gases, and they are causing our world to warm. And Eve will talk in much more detail about that in a moment. And that has all sorts of effects, like rising sea levels and increasing likelihood of flooding events, for example. And you can see this quote here from the IPCC special report, that's the Intergovernmental Panel on Climate Change, that shows that human activities are really making a difference. We've seen 1 degree of warming since pre-industrial levels, and that's in quite a short period of time we've caused that warming. But also at the same time, another crisis is happening, and that's biodiversity loss. And you might sort of know a little bit less about this because it's sort of less in the media. So we're currently losing species at an incredible rate. About 1 million species are currently threatened of extinction. That's being lost forever. You can see from this IPBES Global Assessment that has a very long name. It's the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. So they've done a really full assessment of the state of biodiversity, and we're losing nature at an unprecedented rate. And it's not just losing nature, it's also not just losing species, it's also losing populations of species. So species that used to be really abundant and the World Wildlife Fund found that our planet's wildlife populations have plummeted by 68% by 1970. And that's a really quite striking fact. So these two crises are linked together. They're not happening on their own. Climate change is one of the biggest drivers of biodiversity loss, but also biodiversity loss impacts climate change. If you like, climate needs nature and nature needs climate. But it's up to us to join the solutions to these two crises together. And now is a really important time to make that change because COP26 is on its way. And it's a really important moment for us to push our leaders to fight for not only tackling climate change, but tackling biodiversity loss at the same time. So let me give you a little bit more detail as to what I mean. So first of all, a stable climate is important for nature. So just like us, our species rely on certain conditions in which to thrive. So basically, the way that climate is changing at the moment means that species aren't able to necessarily carry out the normal process of evolution, which means that they change over time and adapt to conditions. Because climate change is happening so quickly, that means that not all species are able to cope, and therefore climate change is one of the biggest drivers of biodiversity loss, as recognized by IPBES, that intergovernmental panel that I spoke about earlier. Here are some examples of how changing climate can affect species. So it can cause, for example, range shifts in species, them moving to new places. That then affects the composition of what types of species are in an ecosystem together, and that can have different effects. It can affect the food web, for example. It can also cause changes in seasonality. So that means the timing of events. So, for example, you might have caterpillars that are hatching earlier in spring, and that means when the baby birds come out later in spring, the food isn't there for them to survive off as it used to be. We can also have increased stress to species, just like us, they get stressed by extreme events like more storms, for example. And also there can be physical damage to systems, for example, coral bleaching, which is shown in this picture, and that is caused by repeated warming events in the ocean, can damage coral systems. Then we have the other side of the coin. So we heard about how stable climate is important for healthy biodiversity, but at the same time, healthy biodiversity is important for climate change mitigation. So that mitigation word basically means we're trying to halt or reduce climate change, lessening the effects of it. And healthy ecosystems are really important for this because they absorb and store carbon in their natural processes. Vegetation and soils take up carbon dioxide. And that's important, as you'll hear more from Eve later, because they're absorbing these greenhouse gases that are causing the warming of our planet. And it's actually thought that ecosystems absorb about 60% of the emissions from human activities every year, the equivalent of that. And therefore, they're really important. And there are some habitats that are particularly key to this, and I'll talk about those in a moment. But we also need to bear in mind that if we damage these special places, they can actually have the opposite effect and release their stored carbon more than they absorb. So in order for them to help protecting us against climate change, we need to protect them. So let me give some more examples. For example, forests are a really key ecosystem that help with this mitigation. Globally, they absorb about 2.6 billion tons of carbon dioxide every year. And that's equivalent to about a third of the carbon dioxide released from the burning of fossil fuels humans emit every year. But as I said, if we damage these ecosystems through deforestation, for example, or forest degradation, then the forests can switch to emitting more than they absorb. And that's a real problem if we want them to help us combat climate change. Hence, that's why I've said forest conservation and restoration is vital for our climate change efforts. Peatlands are a very similar story. I don't know how many people are joining from Scotland, but there's a lot of peatlands in Scotland. I think this photo might even be from Scotland. And basically, peatlands are a specific type of wetland whereby the soil is made up of lots of dead and decaying plant matter, and that stores a lot of carbon. It's quite squishy when you walk on it. And globally, peatlands cover about 3% of the global land surface. And you can see the figure there is in gigatons. That's a lot of carbon that peatlands are absorbing. I think that's more than all of the other vegetation types combined. But same with forests, if we damage these peatlands, for example, if we burn them, they emit carbon dioxide instead. And that's why RSPB is currently in a campaigning to ban the burn on peatlands. And I think members of Parliament are going to be debating that this week. And I'd like to say here, just before I move on, that these nature-based solutions, these using nature in order to combat climate change, needs to come alongside efforts to change the way that we live and reduce greenhouse gas emissions. We can't just sit back and let nature do it all for us. We need to work with nature and also change the way we live. So it's not just climate change mitigation that biodiversity is important for, it's also climate change adaptation. So basically that means that we need, that climate can help us get used to the effects of climate change. So basically, if you have lots of different types of species in an ecosystem, that helps it to function better and it helps it to remain stable in the face of climate change. And if we protect and we restore and we create new ecosystems, that also provides us with services. So for example, if you restore and look after riverbeds, that can help protect us against flooding. You'll hear lots more about that later. And if you can create green spaces in cities, that helps us to cool down and also gives us other benefits like improving our air quality, for example. A really cool example of this in a specific ecosystem is mangroves. And basically, if you haven't heard of them, they're a specific type of plant that grows near water and in coastal areas. And they are amazing in that they help to absorb wave energy. So in storms, they can really help us to protect us from the effect of those storms. I actually grew up in Bermuda, which is a minuscule island in the middle of the Atlantic Ocean, and therefore we really relied on the mangroves on our coastlines to protect us when we were hit by hurricanes almost every year. Obviously, that's me kayaking on a very calm day. I would not be out in a storm, but it can get really, really wavy on the coastline. And the sad thing is that mangroves are actually one of the most threatened ecosystems on the planet. We've lost about a third of all the mangroves we have. Therefore, we need to really make sure we're protecting them we're protecting what's left in order for them to help to protect us as they do. So I've kind of already started to mention this, but how can we basically use these links between climate and nature to drive real action? And there's this term nature-based solutions, which has really been gaining popularity. And basically, they're the way that nature can help us to solve human problems. That can be social and economic as well. And climate change is an example. They involve the protection and restoration, as well as the sustainable management and creation of natural ecosystems. And this is nothing new. Nature has been helping us all through history. But at the moment, governments and businesses and individuals are using this term more and more to raise the profile of how nature can play a really big role in climate change. And also at the same time, it also helps us to tackle biodiversity loss, like I mentioned before, and also gives us other benefits such as human well-being, which is really important for each and every one of us. So just before I finish, I'd like to say, give you a sort of real world example. You'll hear more from Caitlin, but this is an example solution, and it's also really cool because it lets us highlight the amazing work that the RSPB is involved with internationally that lots of people often don't know about. So there is one of our biggest projects overseas is the Gola Rainforest Project. The Gola Rainforest is an area of forest in Sierra Leone and Liberia, which are two countries in West Africa. And that is almost 23 times the size of Glasgow. So it's a really big area of forest. And we're working with our partners in the countries and local communities to protect this forest. And that has benefits for biodiversity, for climate, and for people. So for biodiversity, it's important because the area is a global biodiversity hotspot, which means that there are species there found nowhere else on the planet. Therefore, we need to protect that area to protect them. It also helps us mitigate climate change because the forest stores millions of tons of carbon, and it supports local communities. So we're involved with a project where we support farmers to grow forest-friendly cocoa, which they then can sell on international markets as this Gola Rainforest chocolate, which is really exciting. And that last point is really important on people, because in order to be a nature-based solution, activities have to be carried out with a full engagement of people and support of them. They need to benefit everyone and leave no one behind. It's a really important point to remember. So as you'll hopefully have realized now, or I'm sure you knew before, nature is definitely our ally. And in the past, these connections between nature and climate have often gone overlooked, but now is the time to make sure we raise the profile of nature in this climate conversation, so we can not only protect biodiversity, but also it can really support our fight against climate change, which is really important in the run-up to COP26. So thank you, everyone, and please ask any questions if you have any.
Fantastic, Fiona. Thank you so much for your talk. It was really interesting to hear about your different experiences and the different work that's going on to have a look at sort of working to mitigate the impacts of climate change and biodiversity loss. I had a quick question that I'd quite like to ask is, having grown up in a place that's vulnerable to kind of extreme weather events, have you seen any changes that have happened over your period of growing up there in terms of intensity or frequency of these extreme weather events?
Yeah, it's a very good question. So Bermuda is on, it's the Gulf Stream. So it's this area of warm water that comes up along the coast of the States. So we're actually higher than the Caribbean, so quite a far away, but we still get these hurricanes. And along that whole tract of water covering the Caribbean, recently there's been more and more frequent and intense hurricanes with serious impacts on a lot of communities all along that area. And we've even had sort of multiple hurricanes in the same period of time, which has even more impacts. And it's difficult to say because climate change happens over a long period of time. but it's likely that climate change is leading to that, because if the sea temperature is rising, that gives rise to hurricanes to sort of seed more. So yeah, it is a serious problem, and it does hit home when you're having to shelter from big storms.
And we have another question as well that's come in just now. So what are the RSPB doing to prevent species extinctions in the UK?
It's a really good question. We have, so I work in the global policy team, but there's teams all throughout the RSPB that are specifically focused on species, saving our species, basically. And a lot of it is to do, well, it's lots of different angles they take. Some of it is looking after habitats, habitat restoration. For example, peatlands is really important. That Ban the Burn campaign we have not only is important for climate change, but also the wetland species that make that their home, like curlews, for example, are a threatened species at the moment. And then also we have political advocacy, so whole teams that lobby the government to create laws in order to put nature into law, into the UK's law, to look after our species. And we're running at the moment a campaign called Revive Our World that you can sign up to as a petition that is asking the government for all sorts of things, including new laws and like better farming to look after species. So it's sort of a big integrated approach, but thankfully we are seeing some recovery of species over time.
Fantastic. And another question that's come in just now, just a reminder, you can put in questions into the Q&A box and we will be answering these live as we go through. One of the questions was with regards to peatlands and wanting to understand what threats there were to peatlands. If you could explain on that a little bit more, please.
Yeah, so the way that peatlands have been managed throughout sort of the history of the UK have actually been quite damaging. So there's a lot of grouse shooting that occurs, especially in the north. And basically, they manage the moors so that they can have lots of these grouse, little birds, to increase the population of those birds. And the way they manage it is often through burning the peatland. To sort of cause the vegetation to regenerate every year. And so that threatens the peatlands because it dries it up, so it doesn't, it's not able to regenerate as much, and also that affects the species that live there. And this driven grouse shooting that I think is the most, having the most effect. So we're working hard to make sure we better manage our peatlands, but that involves working with the communities that live there and making sure we can work together for a solution.
Fantastic. Thank you very much. We do have one more question before we move on to the next speaker. And they've asked, when talking about healthy ecosystems absorbing and storing carbon dioxide extremely well, is this in comparison to monocultures such as farmlands?
Yeah, so that's a really good question. So studies have shown that if we have a more diverse range of species in an ecosystem, like lots of different types of native trees, for example, in a forest, it can better function and better absorb that carbon dioxide. But the important thing is storing it. So if you have like a monoculture of trees and they're grown for timber, for example, as they grow, they're then cut down, and in many cases, that carbon doesn't necessarily stay in the vegetation. And for example, farming, that's the case. So that vegetation is cut down every year, so it doesn't necessarily keep it in, and therefore it's not necessarily taking away our emissions and locking it down. So if we use those natural processes, because I mean the world is created in this amazing way that it's got a carbon cycle for a reason. So if we let it stay in its natural state, that's the best way to address this.
Fantastic. Thank you so much, Fiona. That was really interesting. We're now going to move on to our next speaker. We're going to hear from Eve Armstrong, who's a learning officer at Dynamic Earth in Edinburgh. It's an earth science centre with the aim to increase visitors' knowledge of the world around them and their place in it. Eve specifically designs and delivers engaging science programmes for people of all ages, and therefore their role is helping people to understand the role of climate change and science. So I'm going to pass over to Eve just now.
About climate science, and This is a massive topic, so I'm going to do a small whistle-stop tour of some of the essentials. But to start us off, we're going to think a little bit about the greenhouse effect. Now, lots of you said that you knew a bit about climate change and the climate crisis already, so this might be something familiar to you, but I wanted to cover it just in case. So to start us off, I've got a little cartoon that explains what the greenhouse effect is. So here we've got the Earth, and then that black line is just indicating the atmosphere. So we have energy from the sun, comes down through our atmosphere, it bounces off the surface of the Earth, and this becomes radiation. It's heat radiation that we've got bouncing off the surface of the Earth, and it comes up into our atmosphere, and some of it is trapped by our atmosphere. So some of it is trapped, some of it is radiated out, and some of it is radiated back down to the Earth. And the reason this happens is because we've got something in our atmosphere called greenhouse gases. And greenhouse gases are brilliant, we need them. The only reason we have life on planet Earth is because of the greenhouse effect. Without it, it would be way too cold. So this is a really, really good thing, but the problem is we do lots of things on Earth that add greenhouse gases to our atmosphere, mainly burning fossil fuels. And so we can kind of imagine that as sort of thickening up our atmosphere. It's not an actual thickening like in this picture, but more an adding of these greenhouse gases, increasing the amount of greenhouse gases in our atmosphere. So this time, if you imagine the radiation coming in from the sun, it's still coming through, it's still bouncing off the surface of the Earth, but more of it is being trapped by this atmosphere and more of it is being bounced back down onto the Earth. And so we get this warming effect. And there's a direct relationship between the amount of greenhouse gas in our atmosphere and how warm it's getting. Now, one of the things that is often questioned is how do we know the planet's warming at all? So the first thing to sort of address that issue is to look at the temperature of the Earth. Actually, before we do that, we're going to think a little bit about why this greenhouse effect happens. So our atmosphere is made of two main components. It's mostly made of oxygen and nitrogen. And you can see two pictures of what the molecules of oxygen and nitrogen look like. So we've got 21% oxygen, 78% nitrogen, and they're both very simple molecules, two atoms really closely bonded together. Now, these are not greenhouse gases. They're no good at absorbing heat at all. But what we have instead is our last 1%, full of lots of different things, including some of these greenhouse gases. So here on this picture, we've got methane, carbon dioxide, nitrous oxide, and water vapor. And you can see in all these diagrams of their molecules, they're much more complex. They've got double bonds, they've got branching arms, and things like that. And this different molecular structure is what allows these greenhouse gases to trap the sun's energy, to trap this heat and to reflect it back down onto the Earth. So this is why greenhouse gases have this effect. So how do we know it's getting warm? Here's my graph on temperature. So this is average temperature records for the globe over the last 250 years. So we've been measuring temperatures since kind of the 1600s, but only really reliably on a global scale for about this long. And as you can see, there's a bit of up and down, and then there's a kind of general upward trend. But there's a couple of issues with this data. The first being that there's a lot of questions about how reliable it is, particularly as you go back in time. But even with modern day data, it's quite difficult to know how reliable it is. There's been a lot of studies done on where our weather stations are placed and whether they're measuring accurate temperatures at all. And lots of questions about whether we're getting lots of reflected sunlight, we're building too near buildings, and whether this is an indication of us encroaching on our weather stations rather than a warming climate. The other issue is that it only lasts 250 years. The planet is 4.5 billion years old. So this is a tiny, tiny snapshot of the planet's temperature. So how do we know it's not part of a bigger cycle? So there's a few ways that we can sort of expand our knowledge of global temperature and sort of verify this data. And it's by using proxies. So there's lots of different proxies you can use for temperatures. And a proxy is just a way of inferring, of working out what the temperature is without directly measuring it. So they can kind of be split into two categories. One of the ways that we can do it is by looking at the biology on our planet. So up there on the top right of my screen, you can see what are sediment cores. These are basically big drills that drill sort of through the layers on the bottom of a lake. And you can pull up all these sediments, and in these layers, you can find plant material. And you can use that plant material to work out what the temperature was like around that lake through the different years. So we know that certain plants like certain climates, so we can work out what the climate was like. We can do that even further back. Sediment records will work for a couple of thousand years, but if you look in the rock record, like down on the left-hand side there, you can see some fossils, and so then you can start looking into a million-year scale. Another way we can do it is by measuring the chemical components in our atmosphere, because, as we've already established, there's a strong relationship between greenhouse gases like carbon dioxide and the temperature of the planet. We can measure those and work out what the temperature would be. So that's what the Calypso satellite that you can see up on the left-hand side there is doing. It's measuring our atmosphere. This is a NASA mission that's currently flying. It measures the chemistry of our atmosphere and uses that to infer what the temperature is. So it's a lot more accurate. It can measure places we don't have weather stations. Really, really useful information. However, it doesn't help us with our time scale. It just gives us live, up-to-date information. For our time scale to be improved, we need to use our ice core records, which is what you can see down on the right-hand side there. Now, ice cores are brilliant. We take our ice cores usually from Antarctica or Greenland, anywhere we've got this continuous buildup of snowfall. So basically what's happening in these places is snow is falling and it's sort of piling up on itself year after year. It doesn't melt, it just keeps piling on, and it kind of gets compressed under its own weight, and it gets squeezed and squeezed and squeezed and turns into ice. But as it's getting squeezed, it's trapping little bubbles of air, little bubbles of our atmosphere. And it's this paleo atmosphere, this ancient atmosphere, gets preserved in the ice. So we can use a drill, like the one you can see on the right-hand side there, to drill down, take out these huge sort of cylinders of ice, these ice cores, and then measure the gases in those ice cores and work out what the temperature was. So I've got a close-up photo of an ice core here, and you can see these layers. And ice cores get layers in them because the snowfall isn't constant throughout the year. So you get some seasons where you get more snow and some seasons where you get less. And this causes kind of layering year on year. And a bit like tree rings, you can basically just count back the years and work out how old your ice is. Then you can take lumps of that ice, put it inside a vacuum, which is what's happening in this picture here. Suck out all the air, so there's just the ice in there, and then melt it. And then air that escapes into that vacuum, you know, has come from this ice, and you can measure how much carbon dioxide there is, how many greenhouse gases there are, and use that to infer what the temperature is. Now, the good thing about ice cores is they really expand that time frame on our temperature records. And you can build a graph that looks a bit like this. It's a little complicated, so I'll just talk through it step by step. Down along the bottom there, you've got time. So on the right-hand side, it's the present day, and it goes all the way to 800,000 years ago. So we've got this huge record of time. On the right-hand side, we've got our atmospheric carbon dioxide. So this is how much carbon dioxide they found when they melted that ice. It's in parts per million, which is how we measure our carbon dioxide. And then on the left-hand side, this is sort of the conversion of that carbon dioxide value into what we call temperature anomaly, how much it's changed from what is expected. And then the coloured lines in the middle show the results from different ice cores. So we've got different colours for different cores. And as you can see, there's these big patterns, these big highs and big lows that show the kind of natural cycles of our planet. These are our ice ages. So you might have heard of the ice ages before. We've got big times of global cooling and then heating up again. And lots of people argue that this is what we're seeing just now. It's just a general warming of the planet that can be expected. And that sounds very logical until you look at this number here. So this level here, this is our current carbon dioxide level. We've just passed 400 parts per million. This is incredibly high. It's about 100 parts per million higher than anything we've seen in 800,000 years of Earth history. And the reason for this is because by burning fossil fuels, we're adding a lot more carbon dioxide to our atmosphere. So this tells us that it's something we need to be concerned about. Fantastic. That's my whistle-stop tour of climate science. Please let me know if you've got any questions. I'm by no means an expert, but I will do my best to answer those that I can. Thank you very much.
Fantastic, Eve. Thanks very much for that whistle-stop tour. It was very informative. We have one quick question that has come in, and you mentioned the fluctuations of the climate over sort of long periods of time caused by things like the past ice ages. What's actually causing that cyclical nature?
Yeah, it's a really interesting question, and it's not one that anyone has a very clear answer on. There's a few different things that could have caused ice ages. So definitely fluctuations in the activity of the sun could be attributed to that. So we get sometimes the sun has huge amounts of solar radiation, and sometimes, like at the moment, it's very quiet and nothing much is going on. It could also be slight variations in the tilt of the Earth's axis, sort of cooling and warming the north and southern hemispheres. And it's also to do with, there's definitely influence of tectonic movements. So as the continents break up and join together over millions of years, it changes the ocean currents, which in turn can make certain areas very cold and then allows this encroachment of ice. But no one's totally sort of set on what that is. It's a big debate in science.
Fantastic, that's brilliant. Thank you so much, Eve.
No worries.
Really enjoyed that. We're now going to move on to our next speaker. So we have Euan Furness, who is a PhD student at the Grantham Institute and at Imperial College London. He has a background in ecology as well as geology and paleontology. The research in his PhD investigates geographical patterns of biodiversity worldwide and the causes that create them, using newly developed computer simulations. And now I'll pass over to Euan.
Hello, right, let's share screens. This one. Okay, I hope that's working properly. Hi, thanks for coming. I'm Euan from Imperial. I wanted to give a bit of a deeper dive onto the biodiversity side of things and why it's being lost and how can we protect it. A lot of this is going to be kind of general background, but I'm going to touch a bit on my own research as well, just to tell you a bit about that, because it's fun. This is a sort of breakdown of all of the, well, more or less all of the life we have on Earth. There are millions of species of organisms on Earth. We don't actually know how many there are exactly, believe it or not, but it's definitely millions. You probably already know more about extinction than the best experts in the world did 200 years ago, because back then the idea that a species could go extinct hadn't really been thought of. People figured that what was around today was what had always been around and what would always be around, no matter what humans did. They didn't think it was really possible for humans to have an impact on nature. The idea of extinction, where every single individual in a species dies, came from a few different places. One was from fossils of things like dinosaurs. When people started to discover these, they realized that whatever they were, and they didn't really know what they weren't around anymore, and so there must have been a time when the last ones died off. The other place the idea of extinction came from was from people getting better and better at cataloging and naming the animals around them, and then realizing that some of the things that they had named and classified had suddenly stopped being there. It took them a while to realize that this was because all of those animals had died, because it seemed like such a crazy idea at the time. It wasn't something that people thought was possible. But eventually they figured out that was what was going on. They called that extinction. These are two very good examples, two of the best known. The one on the left is the dodo, which you may well have heard of before. The one on the right is a thing called a great auk, which you might have heard of, you might not have. The dodo was a kind of pigeon originally, but it couldn't fly. It only lived on one island in the Indian Ocean, and it was first discovered by sailors who landed on the island in 1598. It gradually became rarer and rarer, partly as a result of hunting for food, but also partly as a result of introduced predators, pigs and rats. And eventually it went extinct about 100 years later. It took people a long time to realize it had gone extinct because it wasn't an idea that they'd ever heard of before. The dodo was very important in that it made people realize that species could go extinct. The great auk was discovered much earlier. They were seabirds, a bit like big puffins or guillemots, for anyone who knows that kind of thing. They lived on rocky coasts all over the west of Europe, including Scotland, and the east coast of North America, all over the North Atlantic. So it's no surprise that British scientists knew about them from early on. They were right on our doorstep. They went extinct sometime in the mid-1800s, about 170 years ago, and they were mostly hunted to extinction. Nowadays, we've got much better at noticing when species have gone extinct. Sometimes extinctions happen naturally without humans doing anything. So there were no humans around when the dinosaurs went extinct, so that can't possibly be our fault. But natural extinctions are very rare and, with a few notable exceptions, generally occur very slowly. As this graph shows, a lot more species are going extinct now than were a few hundred years ago. So all of this is much too fast for it to be natural. On top of that, there's a lot of species that we know about now that look like they could go extinct very easily, especially if we don't do anything to protect them. These are the endangered species, the ones in the warm colors on the left of this graph. And there's quite a lot of them. Some groups are having a harder time than others, as you can see. So gastropods, snails, slugs, that kind of thing, they're doing quite well at the top there, so are bony fishes. But amphibians, like frogs and newts, are doing quite badly. A lot of that's a result of disease. For some groups, if you look at the grey in the middle, there's a lot of that species of that group that we actually don't know enough about to know whether they're endangered. No, that's almost as bad. There are some species that have gone extinct in nature before they've even been formally described by science. We've had to describe them from specimens in museums only to discover that, oh, it's gone extinct. So that's the kind of thing that can happen if we don't prioritize discovering about this kind of thing. So if all this extinction is occurring, then why is it occurring? Well, there's a few different reasons, but the biggest three are introduced species, so often rats or cats or pigs. Humans bring these to places, especially islands, and then once they're there, they kill native species or they compete with them for resources, and the native species have no defenses against them because they haven't evolved alongside them. Another big issue, much more so in the past, but still now for some species, is hunting, where humans have killed large numbers of a species, often for a valuable resource like ivory or rhino horns. And finally, habitat loss, which is becoming a bigger issue now, where humans have destroyed environments where a species lives so they can use the land for something else, like timber or farming, or because of climate change. So this is often the way that climate change can cause species to go extinct. It can change environments to the point where things that used to live there now can't, even if humans haven't been there and affected the environment in another way. I don't want to be all doom and gloom, though. So science is telling us ways we can stop extinction. Sometimes that means making laws to protect animals from being hunted, like with elephants. Sometimes it means getting rid of species that we have added to habitats like by mistake. So rats and things can be removed from islands. And sometimes it means protecting places that species live so that they have enough space to live and the right habitats. That's what some of my own research looks at. The larger an area of land is, the more species it can protect. But we need to know how to split up things like nature reserves so that they're big enough to support lots of species, but also have different enough habitats that they're not all supporting the same species. It's a difficult balancing act. This is a diagram from my own research. It's not especially helpful on its own, but I can explain. So what we have here are the result of several simulation experiments. That's what I work with, where I've changed the areas of the environment we're investigating. That's the x-axis at the bottom. And the habitat heterogeneity. You can think of that as the number of habitats. That's the different colored points. And then you let the simulation run to see how many species can coexist within it and how many get driven out. So I work with simulations because people have tried to study this kind of thing in the real world, and it's really quite difficult. It's hard to be sure how much of a difference in biodiversity between areas is down to a difference in size and how much is down to all the other possible differences in those areas in the real world. So what we find in our simulations is that the size of an area does matter. You can see that these lines are increasing as they go to the right. The bigger an area is, the more species it can support. But habitat heterogeneity matters too. So for any area, regardless of how big it is, the more habitats it has, you can see the scale on the right-hand side is increasing number of habitats as you go down. The more habitats it has, the more species it can support. So it turns out there's a bit of feedback as well. This isn't a straightforward system, but this is the kind of experiment I run to look at it. And there are success stories from conservation. I don't want to leave everything doom and gloom, so I'll tell you about this guy. This is a Chatham Island black robin. They very nearly went extinct. In 1980, there were only 5 of them. Only one of those 5 was female. But with a lot of hard work from a lot of dedicated scientists and conservation workers, they've recovered. And now there are 250, which is not a lot, but it's much better than it was in 1980. I hope this has been interesting. And if you have any questions, I'd be interested to answer them. So thank you.
Thank you very much, Euan. That was fantastic. Just a reminder again, if you do have questions about what our speakers are speaking about this evening, you can put them into the Q&A box and we'll happily answer them. I did have a question, just again, a little bit about the Chatham Island robin that you mentioned just at the end there. What kinds of measures in terms of conservation measures were put in place to really kind of help support that bird when it was down to such low numbers?
Excuse me. So the Chatham Island black robin is a fairly exceptional case because it went down to literally 5 individuals. Most endangered species don't go that low, and they can be helped by things like getting rid of whatever hunting they're experiencing or getting rid of invasive species. In the case of the Chatham Island black robin, people took a rather more extreme approach where they knew that they would lay multiple clutches of eggs. If you took the first one away, they'd lay another. So they wanted to maximize the number of chicks they could hatch. So what they did was conservationists tagged every bird. That's, you can see in the picture, there's a metal ring on its leg that has a unique ID on it. they would take the first clutch of eggs off every female, and then they would give that to another species of bird, and they would replace its eggs with these eggs. So they'd have another species of bird that was acting as a surrogate parent for half the population. They also kept very close tabs on where every single nest was to make sure that they were doing okay. There was actually a big problem at one stage because they were being so, the conservationists were working so hard to make sure that every single chick survived. Some of the chicks that started to survive had really quite deleterious, damaging mutations that if they had spread in the population at large would have been a big problem for the long-term survival of the species. So there was quite a, it's a classic case now, and there was quite a difficult decision that had to be made at one stage by a conservationist, which was, we have to let some of the members of this species that is incredibly endangered and we really want to protect, we have to let some of them die. Because if we don't let the ones die that have this horrible problematic mutation, then the whole species is going to go extinct once we stop looking after it. So there were some really quite extreme and intense measures taken in that particular case, just because it was so special.
It definitely sounds like a really fine balance. And I think that's one that often comes up in conservation, trying to find that balance. I've got one more question. Are there any ways that citizens, people just in their day-to-day lives, can take action in supporting the recovery of a species? Do you know of any in the UK that we can help support?
Well, the groups like the wonderful RSPB are involved in such things, so supporting them is great. There are certainly endangered species in the UK and species that need support. So wetland species especially have suffered a lot from land development for things like agriculture. More broadly, a lot of the threat to species in the future is either going to come from climate change or from intense land use. So anything that you can do in your life that mitigates your effect on either of those things is going to be beneficial to biodiversity as well. So that might mean eating less meat, or it might mean any other measures that reduce your carbon footprint. Things like ethically sourced palm oil or other sourced things that reduce impact on areas of exceptional biodiversity like rainforests as well.
Fantastic. Thank you very much, Euan. That was a really interesting talk, and thank you for answering the questions. We're now going to move on to our next speaker. Caitlin is a graduate student who works with local people who look after rivers and the areas around them. She is finding new ways of working to show the benefits of natural methods that can provide clean water, reduce flooding, tackle climate change, and be a home for plants and animals all at the same time. This way, the people who decide what our local areas look like can make sure they plan for a sustainable future. Thank you very much, Caitlin. We look forward to hearing what you talk about.
Thank you very much, Kate. Just get this up for you. Okay. So, as Kate said, my research is all about finding out how nature can be the solution to those problems. And so, as Fiona mentioned earlier, there's these things called nature-based solutions. And they are ways that we can tackle issues of climate change and biodiversity loss while supporting our natural environment. But there's sort of two strings to this. And Fiona mentioned quite a lot about restoring peatlands and conserving forests, but my research is more focusing on how we can put these nature-based solutions into our urban areas or into other areas that we live in the rural landscape too. And that means that we can use nature and work out the way in which it responds to change to benefit us as well. But let's look at an example of this. Here we have a river, and next to it is a field. And on this nice sunny day, the river is just flowing happily along its riverbed. Unfortunately, in the UK, it rains quite a lot. And that means that we get floods. And this is because the water level rises and it floods over the top of our green spaces. Now, in the natural environment, fortunately, nature knows what to do. Over a period of time, when the flood is going backwards and forwards, it's building up soils and it's changing that landscape. And eventually, things like wetlands form. I think Euan mentioned earlier, wetlands are one of the most biodiverse landscapes that we have in the UK because they manage to support so many other animal species as well as plants. But unfortunately, humans get in the way of this, and we go and build houses on floodplains. And that means that it still rains, because we're still living in the UK and we still get that rainy weather, and we still get floods. That means our houses are at risk from flooding, and this puts people's lives at risk and people's livelihoods, and that's not good. Now, usually our response so far has been to just put up a barrier, completely block out, stop the flood from coming any closer. But that only really has one benefit, stopping the flood. But what we can do is use nature as a solution to finding other benefits as well as stopping that flood. So instead, we come in and we construct our own wetlands to absorb water. Now, this has the fantastic advantage of reducing our flood risk, because it's stopping that water from getting to the house. That's our first benefit. There are so many more. As I said earlier, wetlands are hugely biodiverse, which means they are supported by lots and lots of animal and plant species. So we get wetland birds, we get insects, we get fish, we get loads of species living in this area. And all of these species have like a system interconnected with them, and they support the whole system globally eventually. But there's other benefits to us humans too. Wetlands are able to filter water, which means that we can use it for drinking water or washing. Wetlands also absorb those gases that Eve was speaking about, the greenhouse gases. They absorb and they store them in their soils. And if we leave them there, then we can start to alleviate climate change, which means undo what we've done by producing greenhouse gases by burning fossil fuels. But there's actually some more direct benefits that having nature-based solutions like wetlands in urban areas can have to you at home. By building a wetland within a park that floods quite a lot, you can make other areas of that park more accessible for playing sport and other recreational activities like bird watching, going for a walk, reading, or just enjoying the sunshine. And I know that I've really benefited from green spaces in my urban area during the lockdown. And so it'll be so good if we can make these spaces accessible for people. By making these spaces more safe, we also make our roads safer, which means getting to work and getting to school is easier too. So if we don't have floods on the road, there are fewer accidents. And now all of these things together, they mean our mental and physical health is improved. And that's the real win. Because a combination of all of these things means that we can demonstrate to the decision makers, the grown-ups that make decisions about our local areas, why they should put nature-based solutions in to at the local area. And that's what my research does. So I use concepts like green space and work out what different benefits are. So green space can have a few. We've already talked about flooding, and we've already talked about biodiversity, and we've already talked about public space. And these are already positive things. Sometimes there are negative things. The green space in urban areas can provide more areas for crime, which is not a good thing. But in balance, often nature-based solutions do win. Now, the models that I work with look a little bit more complicated than this. This is pretty much what I'm working with on every now and again. Now, I take models like this to decision makers and use them to demonstrate what all those benefits are. Now, this one's a bit complicated, so let's break it down. We've got some different areas here. So at the top, population change, the way in which our population structure is changing, people moving out, people moving in, new people being born. There's also the natural environment, our green section on the left. That's the blue space, the green space, our parks, lakes, rivers, canals that we go and see and enjoy. Then in the middle, we have urban design, and that's the planners making decisions about what areas of urban space they're going to change to be new shopping centres, new schools, hospitals, all of those different types of things. And at the bottom, we've also got how we use that space. So that's going to affect the quality of it, because as we use things, the quality changes if we don't maintain them properly. And that brings us to our last point, maintenance. It's really important with spaces in urban areas, because we use them, we need to make sure that they are sustainable and they are looked after for the future. But unfortunately, all of these benefits don't benefit everyone. There are barriers that exist to people being able to access those benefits. And that could be due to culture, it could be due to where they live. It's so many reasons. And it often means that the people that face more challenges in their day-to-day lives don't meet those benefits. And so I think that when we can demonstrate to our decision makers, the grown-ups that plan how our world looks, that we can have these benefits for everyone, we should use them to really combat the inequality that exists within our country. And we can make these benefits good for everyone and accessible for everyone. And I think that is a great idea. Now, we have got some examples of where these have been happening a little bit closer to home than some of the examples that Fiona was talking about earlier. And one of those is Cairngorms Connect. It's a project going on in Scotland that's restoring the natural world by using nature-based solutions. So here we've got a picture of a deer, and they are managing that population of deer to make sure that it's providing the services that it should be. There's also one that's happening possibly in your local urban area. The pollinator strategy for Scotland is something that's going on at the moment, where we're increasing the amount of wildflower species that are existing within urban areas. This supports bee populations. And I'm sure some of you have probably heard about the fact that the bees are going extinct, and that's not a good thing. And the reason it's not a good thing is because bees provide a vital service for pollinating our food sources. Without bees, we simply wouldn't have enough food. And so we can provide their habitat. And this is one of the ways that citizens can get involved with helping with endangered species, which is something that someone asked earlier. If you make your green space, your garden, your window box, just like a little planter outside your house, more environmentally friendly for pollinators by growing some wildflowers or anything that has flowers on it, you are going to be able to provide a home and a habitat and a nature-based solution for those species that we really need to support our society. But there's another part of this that's really important, and that's how you at home get involved. Now, when we do nature-based solutions, you might think, oh, that's just someone else that's going to plant that tree or build that wetland. But actually, if we get you, the young people, involved, then we can really start to make a difference. Because you being here means that you benefit from those nature-based solutions straight away. You're learning, and you're getting excited about the difference that you can make for climate change. And that is why nature is the way forward.
Thank you so much, Helen. That was fantastic. Really enjoyed that, and particularly the kind of linking together the different aspects of your work. It's really fascinating. We are running a little bit behind schedule, but we do have a quick question, so we'll try and answer that just now. So we've been asked, what are some of the ways coastal regions in the UK could decrease land erosion in a sustainable way?
That's a really good question, because coastal erosion is quite a big problem in some parts of the UK. And unfortunately, it's actually quite a natural process. And that's simply because of the way that our environmental system is set up. So in some cases, you do need to protect the homes that are there. And the best way to do that is to simulate what would normally happen in a natural environment. And if you imagine an open beachland that's quite healthy, if you think, it usually has a dune system. And that's because there's lots of plants and animals that are forming roots in the ground, and they are holding in the sand, and that provides a barrier between the sea and where we live. And so that's kind of a nature-based solution for protecting coastline in the UK. Unfortunately, in some circumstances, there will be cases where we as humans just have to accept that the natural environment wants to be there, and it's a shame, but sometimes we have to make those compromises with nature in order to move forward in a more sustainable way.
Fantastic, thank you very much. Okay, we're going to move on to our final speaker for this evening. I'd like to welcome Rachel Osgood from UN House Scotland. Rachel is also an undergrad student at the University of Edinburgh studying sustainable development and social anthropology. She works as a co-leader of UN House Scotland's climate justice team and as a core member of the COP26 coalition, which is a broad, diverse and inclusive UK-wide coalition organising around COP26. Her background is primarily in areas related to justice, policy implementation, and youth engagement and youth power. She has worked as an award-winning speaker, artist, and advisor on arts-based community development programs in Texas, where she's from, and on national level projects for youth voice in social justice issues in the US as a whole, and as a policy researcher and analyst for a variety of organisations here in the UK. like to welcome Caitlin. Not Caitlin, Rachel, apologies.
Hi everyone, my name's Rachel. Thank you so much, Kate, for the introduction. I'm just going to pull up my slides here and we will get going. My apologies. So I'm here essentially to kind of bridge everything that we talked about in the last four wonderful sessions, the last four wonderful talks. We've discussed the science, we have discussed the impacts of climate change, and now we are going to ask, what do we as youth have the power and capacity for to translate this information not just into meaningful action, but meaningful impacts? To ask, what is the relevance of these really large and complex systems of international politics and negotiations to our lives and to our futures? And what is the best way for us as young people to be a part of that change? So the first question then to ask is, what is COP? COP26 is an international summit of all the countries which are a part of the UN Climate Change Treaty, which is the UN Framework Convention on Climate Change, or UNFCCC. 197 countries are a part of this process, and they are known as parties to the treaty. The United Kingdom, specifically in Glasgow, is set up to host the meeting, originally planned to take place in November of 2020, but has been postponed to 2021 due to the COVID pandemic. That's one of the reasons why this event is so important to us. It's happening right here on our doorstep. COP involves a lot of multilateral decision-making, meaning that it happens across many different groups, platforms, levels of power, etc. During the 2 weeks, there are lots of negotiations. Inside the conference, in what's called the Blue Zone, delegates such as politicians, diplomats, campaigners will hold lots of different formal and informal meetings. Businesses and civil society organizations get to contribute as observers, with more than 30,000 people attending. That means tons of events, conversations, movement building, and influence on the negotiations. Lots of COP negotiations center now on what is called the Paris Agreement. For many of you who have heard of it, the Paris Agreement is essentially an international handbook to tackling climate change. In it, nations agree to three things, roughly. To reduce the amount of harmful greenhouse gases produced and increase use in different types of renewable energy, to keep the global temperature increases well below 2 degrees Celsius and try to limit it to 1.5 degrees Celsius, and to create financial systems to help poorer countries recover from and potentially mitigate ecological disasters that are bound to happen as climate change threats increase. Now, because the Paris Agreement was created at COP 21 in 2015, and it is renewed or reviewed every 5 years, that makes COP26 incredibly important. It's a year that's going to determine the next decades. Decisions being made now by governments around the world will shape our societies for years to come. Decisions that can either further entrench global and local inequalities, or alternatively, put people and nature-based solutions first. As well, COP26 is the largest gathering of world leaders ever to take place on British soil. And while that's not particularly relevant to what is COP, I thought it was really interesting and kind of cool. So what is the role of youth in COP? According to UN estimates, there are 1.21 billion young people between the ages of 15 and 24 in the world today. That's accounting for 15.5% of the global population, roughly. With youth climate movements growing around the world as well, this has given space for the development of what's called a youth constituency. At COP, this is called Youngo, and it consists of many youth-led organizations, groups, delegations, and individuals around the world working in climate change-related fields. They run various working groups focusing each on specific aspects of climate change within the UNFCCC, as well as observe and report on climate negotiations and the implications of their outcomes. So I wanted to talk a little bit about different ways of accessing climate change related engagement, because COP is very high up on an international scale, and it can seem something that that's hard to access. I myself have never been. I probably won't attend until next year or in future years, but and that's for a lot of different reasons. You know, youth and power have always had a very difficult relationship. There are questions of not being taken seriously, of not having enough experience to participate in these types of events or conversations. The example I want to bring up is that one time I went to represent Euan House Scotland at an event by the Scottish Government, where they were going to review Scotland's 2019 Climate Act with a lot of different organizations. RSPB may have been there as well. And I sat there, I was 19 at the time, and I sat there as probably one of the only people under the age of 27. And during a break, one, to put it delicately, stuffy old man kind of questioned me, and in not so many words was telling me that it probably would be best if I sat kind of quietly and didn't contribute much, implying that I didn't have, as a young person, much to contribute. So in a kind of cheeky move, I made sure to sit at every single table that he was at for the rest of the conference and ask as many questions as I possibly could. And that actually worked really well, not just in annoying him, but also I realized that as a young person, I had a really good ability to ask questions that people were afraid to ask questions that got the conversation moving back towards these fundamental issues that are at stake in the climate conversations, and shaping the entire way that discussions were being held in a way that was more equitable and more just. So, you know, that is to say that involvement in these types of things happens in so many different ways. I have this slide up here of tons of organizations that are connected to RSPB, that are youth related or interested in a lot of the same subjects as RSPB here in Scotland. I have taken a very weird and not linear route towards my engagement with climate change through official organizations, but also just through, you know, community engagement, and all of it is important, and all of it is doing work that is vital. I wanted to mention really quickly this event now that I am working on with the COP26 coalition from the ground up. It's a 5-day international conference about climate justice, which RSPB is actually organizing an event for. What does nature mean to you? Which one of our lovely speakers, Fiona, will actually be speaking at. So we are very excited, and you should absolutely come. And it will get really more in depth on a lot of these questions that we've discussed today during this webinar. Similarly, Youth Rise Up accesses a lot of questions and conversations around youth activism with the Scottish Youth Climate Strike and the UKYCC. They're really great organizations doing amazing work. And if you're looking for access points into a lot of different subjects related to climate change and how you can get involved, these are the way to go. They're really, really great, and they're happening over the weekend. So I just wanted to kind of close with a little bit of a note that we are in uncharted waters. The fight against climate change is quite literally the fight of our lives. Climate justice is not simply about carbon emissions, but is also about the inequalities in the world that are deeply felt and experienced by millions. We face not just one singular crisis of the environment, but multiple crises. That of ecological destruction, of rising temperatures, biodiversity loss, of poverty, hunger, racism, health, and forced migration. But in the same way that we face multiple crises, we have the potential for multiple solutions. In fact, it's a necessity. In your everyday life, in the big things and small things which you do to engage in these issues, do not ever let someone try to take away your ability or skills to actively shape your future, to actively shape our future. As young people, our power is to hold two truths, that which we know and that which we don't. In reality, this applies to any person you will ever come across. But there's a way in which young people use this relationship between these truths to our advantage that is critical in both political engagement as a whole, and especially in engagement with climate issues. We can understand very deeply the challenges the world faces and what that means for our futures. But we also don't see the areas where we still have things to learn as a barrier to engagement. It's our opportunity. Take what you don't know, take your questions, ask them critically. It is through your continuous engagement with your learning, with your education, with your everyday interactions with organizations like RSPB or Youth Strikers that these systems begin to change. It is from these continuous, multi-generational, multi-organizational commitments to climate change and biodiversity movements that I am reminded again and again how the growth of such enterprises, whether RSPB's Youth Council or UN Health Scotland, cannot be disconnected from the character of those who work within it. I always have and always will believe in the power of youth. We find strength and we find meaning in what we work towards. Our power is our hope for the future and in the choices we are making now to fight for it. Thank you.
Thank you so much, Rachel. That was a really important talk, and just to say those are some really inspirational words, and I really hope people feel that passion and can feel that spark, and it'll encourage them and inspire them to continue down that path as well. So that was all of our speakers for this evening. We have 2 minutes or so if anyone has any further questions, but I do have one question that I just would like to ask you, Rachel, is with COP26 happening next year, what is your one hope for COP26? If you could have anything happen, what would be your hope?
So many things. I think last year at COP25, there was a lot of international annoyance is not strong enough of a word, but upsetness at how little was actually done and achieved in the negotiations. And I think the world desperately needs, something to move forward concretely in international legislation. But on a personal note, there's absolutely something to be said for, yes, we need these concrete international treaties. We need to move forward globally, but also there is so much to be said for these more third sector or civic organizations and kind of spaces outside just the negotiations and the delegates at COP. And through, COP is 2 weeks. There's decades more of work to be doing besides these 2 weeks, and it's places like RSPB, it's places like UN House and the COP26 coalition and everything that people are doing in their everyday lives that really fundamentally move forward climate change initiatives. So, it's a mix of both policy and continuing movement building, I would say.
Still muted. Fantastic, thank you so much. We do have one question that's also come in just now. It sounds like from a fellow student in sustainable development. And the question was, how did you get into working with UN House Scotland and what was your route into that?
Very random, I completely fell into it. I found them outside the library at the University of Edinburgh and they were looking for people to get involved, and I applied and I was accepted. But a lot of, there are so many different wonderful organizations looking for people. UN Health Scotland will always take more dedicated people looking into climate change and all sorts of different issues. But I would say, once you kind of break into that space, once you're able to kind of access a little bit of these organizations, it becomes so much easier to network and see everything. So all you need is one small access point. And once you find that, once you're able to go through that, everything opens up. So keep looking and, the world is absolutely your oyster.
Fantastic, thank you, Rachel. And I would completely agree with that point. Having conversations with people who work in these fields, introducing yourself, can be quite scary and quite intimidating, but I would wholeheartedly encourage you to do that. It's through those conversations that I found myself in my positions and the jobs that I've worked in. So go and have some conversations, ask some questions, as Rachel said. So thank you very much to everyone who has come along this evening. If you do have any further questions, please feel to direct them to me. We have one final slide. which just has a little bit more information. If you're interested in the COP26 climate change project that I'm working on, please do feel free to contact me. I'm Kate Kirkwood or kate.kirkwood@rspb.org.uk. As Rachel also mentioned, there are lots of events happening from the ground up, organised by the COP26 coalition. There are some fantastic talks, some really inspiring talks going ahead. There's one tomorrow around youth, which I think will be fascinating. And also keep an eye out on RSPB Scotland on our social media channels for future events that come up. I just would like to extend my thanks again to all of our speakers, to Rachel, to Caitlin, to Euan, to Eve, and to Fiona. And a thank you to my colleagues behind the scenes who've making this happen absolutely smoothly. You've been superstars. And I would also like to thank Scottish Power, who have made this project possible thanks to their very generous funding. Thank you all so much for your attention this evening and joining us. We hope we've started you on a pathway to learning more, or it's inspired you to go and find out more about how you can be involved in working towards a better planet and to reduce the impacts of climate change. Thank you so much. Take care.